Hello, in this part we will continue with the next section of our recommendation system. We call it matrix factorization. First, we have to create a file called model.py. And we have to import some important libraries. Import the PyTorch library, which provides functionality for building and training neural networks. And import the torch-NN module, which contain important classes and functions to build neural networks, such as layers and loss functions and etc. Next, we define a class called matrix factorization that extends NN module, making it PyTorch neural network model. And after that, we have a constructor of class which takes three arguments: num users, num items, and embedding size. Num users, that is 50 by default. On this line, we call a method super that calls the parent class constructor, NN module, necessary for PyTorch to properly initialize methods and properties. Next, on the next line, we create embedding layer for users, learning vector of size, embedding size, that is by default 50. And after that, we create embedding layer for items, learning a vector of size, embedding size again, that is by default 50. On the next line, we have a fully connected layer that reduces the combined embedding size to a single output. After that, we are creating a new method called forward that takes two arguments, user and item. On the next line, we are retrieving the embedded vector for each user in the batch based on the user ID. And on the next line, we are retrieving the embedded vector for each item in the batch based on the item ID. On this line, we are performing element-wise multiplication, combining users and items latent factors, and each element now represents aspect of their user-item relationship. On this line, we sum the elements of the interaction vector along the embedded dimension, dim1, which represents the predicted interaction score. And on this line, we return the predicted interaction score for each user-item pair in the batch. If we have to summarize the file, this module learns latent factors for both users and items and uses those factors to predict a score or rating for user-item pairs by multiplying and summing their embedding vectors. It's a common collaborative filtering approach for recommendation systems. And with this, we finish our lesson about matrix factorization in our recommendation system.